Ketchup is a solid. Actually, scientifically, a solid. The reason it won't come out of the glass bottle isn't that it's too thick. It's that at rest, it isn't flowing at all. It has structure. It has yield strength. It behaves like stone, on a smaller scale, until you apply enough shear stress to break it. The trick, tap the 57 on the neck of the bottle, is Heinz's own recommended method, and it works because it applies exactly the shear force needed to overcome that yield strength. The bottle isn't the problem. Ketchup isn't the thing you think it is, and that's the reason why. Everyone who has eaten inside an American diner has done this. You pick up a glass Heinz bottle, turn it upside down over your fries, and wait, nothing at all happens. You shake the bottle once, still nothing. You shake it again, harder. A few drops dribble out the lip and land on the edge of the plate. You shake a third time, and suddenly, a landslide of ketchup crashes out all at once, covering everything. This has been happening in restaurants for roughly 120 years. It's not your fault. It's not the bottle's fault. It's not the ketchup's fault. What you're looking at is one of the most famous physics problems in the whole condiment world. The easy answer is that ketchup is just too thick. That answer isn't wrong. Exactly. Ketchup is thick, but it misses what's actually happening inside the bottle. Melt ice cream, and you get a liquid. Pour olive oil, and you get a liquid. Water is a liquid. All of those substances get a little thicker as they get colder, but they still all pour. They just pour slowly. Ketchup doesn't behave that way. A cold glass of water is 1,000 times thinner. Sure, but the water still moves the moment you tip the glass. Ketchup just sits there. It holds its shape. You can balance a penny on top of sitting ketchup. No liquid does that. The physics name for what ketchup is doing is non-Newtonian. Isaac Newton's definition of a fluid was something whose viscosity stays constant no matter how hard you push on it. Water is Newtonian. Oil is Newtonian. Ketchup is not. Ketchup is what physicists call a shear-thinning fluid. At rest, it has a yield strength. It behaves like a solid. It holds its shape. It will not move. But the moment you apply enough force, that structure breaks, and the ketchup becomes thin and runny. The more force you apply, the thinner it gets. Ketchup is the textbook example. Toothpaste, blood, and quicksand are all the same. All non-Newtonian. All solids until you shove them hard enough to become liquid. Now, here's the part that's almost too perfect. Heinz, the company selling the famous glass bottle, has known all of this for over a century, and they printed the solution to the problem directly onto the neck of every bottle. On a classic glass Heinz bottle, you'll see a little raised 57 pressed into the glass at the slope of the neck. Heinz tells you to tap that exact number firmly with the flat of your palm to get the ketchup to flow. Most people assume it's decorative branding. It isn't. The 57 marks the exact spot on the bottle where an angled impact transmits the most shear force into the ketchup inside. The tap is the yield breaker. When ketchup does finally pour out, it pours at roughly 1.028 miles per hour. That's 45 meters per hour. That's actually slower than a garden snail at top speed. If you started a ketchup race with a tortoise, the tortoise would win by about 4 meters in the first minute. And that's the fast version, the flow rate after you've already broken through the yield stress. Before the tap, the actual flow rate is exactly 0, not slow, 0. This is why the University of Queensland's famous pitch drop experiment, which has been measuring the flow of asphalt since 1927, is the longest-running laboratory experiment in history. Ketchup is just barely faster than asphalt. There's one more oddity. The number on the bottle, 57, has nothing to do with the ketchup. Henry Heinz was riding a train through Manhattan in 1896 when he saw an ad in a shoe store, 21 styles. He liked the phrasing. A specific number attached to a product made the brand feel modular and thorough. So he decided his own company should have a signature number. He picked 57. It wasn't the actual count of Heinz products. The company had well over 60 at the time. He simply liked the way it sounded out loud. Every single thing Heinz has made since that day has been stamped with the arbitrary number from a train window daydream. In 2012, a team of engineers at MIT invented a coating they called Liquiglide, a slippery food-safe polymer you can spray inside any container. Ketchup on Liquiglide has nothing to grip. Tilt the bottle and everything slides out in under 2 seconds. No tap, no ritual. The MIT team spun out a company. Heinz experimented. For modern plastic squeeze bottles, Liquiglide is now quietly in use. For the iconic glass bottle, the one with the embossed 57, Heinz kept the ritual. Tapping the number is part of the brand. The physics problem isn't a bug anymore. It's a feature. A flagship piece of marketing built on the idea that you have to earn the ketchup. The next time you sit down with a hot plate of French fries in an American diner and reach for a glass Heinz bottle, take a second before you shake it. What you're actually picking up is not a liquid at all. It's a solid with a yield strength. It's physics behaving like stone until you break it. The ketchup is going to sit at the lip of the bottle in total defiance of gravity, and it's going to sit there because ketchup does not flow under its own weight. It requires a shear force of about 15 pascals to start moving in the first place, which is why a gentle tap with the flat of your palm on the 57. The arbitrary number Henry Heinz picked from a Manhattan train window in 1896 is the exact amount of force needed to liquefy a tomato product. The bottle isn't broken. The ketchup isn't defective. Nothing about this situation is malfunctioning. You're holding a non-Newtonian fluid in a glass container designed by a man who had never taken a physics class, solved by a random 19th century branding decision, and still followed in every American diner and backyard barbecue today. So earn the ketchup. Tap the 57 on the neck of the bottle, firmly with the flat of your palm. So that's just one of them. There's a whole quiet archive of stories like this, hiding inside ordinary objects you never once thought to question. Subscribe so the next one finds you first.